Alright. Should be streaming. Go ahead and walk on stage. Let's mute my Twitch page. Twitter, bots, and, well, bot singular. And Discord. Alright. Think we are good. So, hello everyone, this is Chris Ingerson, and it is February 24th. It took me a second to read my own dates. And this is the February 24th TextQuest Devstream. So, today is Saturday. We're going to be resuming our work on custom text-based adventures. And I guess before I forget, I should go ahead and have... Ta-da! We're going to be doing a lot of code today, as we tend to do every time we do custom adventures. Alright, so last week we got in-game screens to function. So you can customize what is shown in in-game screens. So you can do things like turn order, or not turn order, turn count, time spent playing, things like that. And that's basically the most that we can do with the in-game screens until we get custom logic set up. We're going to start off today by doing, not custom logic, but we're going to instead focus on profiling and optimization. Because I'm kind of curious where my... Oh, this is interesting. I have never seen that warning before. Interesting. Well, that's not great. Okay, well anyway, so let's go ahead and go over to author mode to just get a sense of the current state of affairs. So if we go over to, let's just go ahead and test the game and then quit out to show you what we did last week. I'm going to say yes. So we get to show a custom in-game message. We can show a variety of different messages that we want to have displayed here. In this case, we have score, then time played, and then turns. As of right now, the turn count is not accurate, and the time played is not accurate as well. So once we're done profiling our existing code, we'll probably fix those couple of issues. The turn count shouldn't increment when quit is typed or when your response to quit is input. Currently it is. Or at the very least, it's done for one of those two things. Presumably it's done for this one right here, this Y. Presumably. Might actually be this quit one up here. But in any case, we need to not have either of those actually do anything. Hello, Apollo I. Welcome back. How you doing today? So that's the current state of things. And let's go ahead and quit. Oh, that's so much nicer. Oh, yes, and I did fix that 40-second quit lag that we had when quitting back to the splash fade screen, or scene. It was a stupid thing, and I'm mad that that's what it was, but we gotta live with it, so. Alright, let's go ahead and close some of the stuff that I didn't need open. Get rid of a bunch of stuff that I had open while I was optimizing. And I apologize, by the way, that I had kind of a sporadic streaming schedule this week. I had a lot of work stuff that went on past my normal Devstream times, so it was kind of hard to get back in time to do that stuff. So, all gravy? Well, that's good, that's good. It's always nice to be gravy. Or groovy. Or both. Groovy gravy. Or would it be gravy groovy? No, it'd be groovy gravy. I don't know. Both of those sound like band names and or song names. Alright, so I want to open my profile window. I don't know why I went into Visual Studio. We're not debugging anything yet. So I'm going to go ahead and open up Profiler. Ta-da. And we're going to dock this so you guys can see what we're getting. I'm going to go ahead and deep profile. And we are going to have to turn off maximize on play once deep profile is, initialized. When you turn on deep profiling, it lags the editor, so I'm clicking on a bunch of stuff and you'll see that nothing's actually highlighting. I don't know what it's doing. I'm assuming it's doing something on the back end for the game engine to let it know that it's doing deep profiling. Alright, we're going to turn off maximize on play. That way we can keep an eye on our profiler, see where anything really intense pops up. And yeah, let's just go ahead and play. I'm assuming that the most intense parts will be when we initially open it, and probably when we open the actual list of existing games. just because it has to parse a ton of JSON whenever it does that, and that's probably going to generate a fair amount of garbage. Okay, so we're going to go to start, we're going to go to extras, we'll go to author mode, and let's go to create. Yep, there was that initial spike. Let's go to Zork. I'm curious where this giant lag is coming from, so we're going to go ahead and stop here. So we have a, wow, almost 200 milliseconds. Let's go ahead and drag this down. Give us a lot of space. Let's see here. Move this up. All right, I'm also going to do it by GC allocation. I'm assuming this is going to be our not JavaScript, our JSON stuff. Let's see. It's the only thing I can think of that would generate this much garbage. It's got to be. I'm sure we have to drill through a bunch of stuff to get there. Come on. we're getting there. Oh, interesting. Event on pointer up also generates garbage. Okay. Let's go back here to Unity event.invoke. Yeah, we're just drilling down basically all the way to eventually when we get our stuff parsed. Right. Okay, so we have a little bit from the UI.get. That's understandable because it's looking through a list and instantiating stuff. This gives our refresh list, generate buttons. Jeez, all this stuff. Okay, I thought for a second that recycle button was actually getting us something. Really, text quest view itself gives us garbage. That's interesting. Oh, hex to color. We can get rid of that. Select input, listen for submit, which is actually something we can probably optimize right now. This is I believe this is a coroutine that I have running. Let's go ahead and pull up text quest view. All right. So, right. Let's go peek this real quick because this is going to give us some wonderful, and by wonderful I don't mean wonderful at all, I mean pretty annoying. Okay, so that's actually not doing nearly as much as I thought. That's just, really? Color check is, oh, that wasn't the thing that was generating garbage, actually. That was, I mean, it will generate some garbage because we have a string going on there. It was color to hex, or hex to color. But that's not in this menu, I don't think. Okay, so here we are. Listen for submit. Now, the question here is, do I actually need this? I think I might be able to get away with this in update. And what I would do there is I would have in update if is open and is listening for submit, then we're going to do stuff. Because then that gets rid of an entire coroutine that we have running that has to happen every time a menu is opened. The flip side is, though, that means we'd have updates in all of our menus. Well, yeah, on all of our menus. But that's not a ton of performance overhead, really, because they're going to be deactivated most of the time, which means they wouldn't get those events. Well, actually, they wouldn't be deactivated. They would just have their roots deactivated. I'm still going to say that having an update tick sent out to I don't know what, as at most probably 20 menus, if that even, is still going to be less. Well, it's going to impact performance less than having a coroutine spin up every single time we open a menu. I think it would just be better to have this in update. So let's try that. So we're going to say protected virtual void update in case the stuff needs to be overridden. For the most part, update shouldn't really need to be overridden, but we need to be ready for it. So we're going to say if is open and is listening for submit. Then we will say, let's see, if input.get key down, key code dot return, or, well, not animation, or input.getKeyDown, key code, keypad, enter, relatively minor thing. And if that's the case, then we'll call on submit. So the reason that I have to do this instead of relying on the internal returns, basically the internal functions in text fields that let you just hit enter, is because that event will also be sent if you click off of the input field, and we don't want that. We only want it when you expressly hit enter, not if you click off of the input field. Okay, so that is pretty simple. Let's go ahead and find all references here. Unfortunately, we do have to keep select delay in a coroutine. We can't get around that, which is really annoying. Really, I have multiple start coroutine. Oh, it's wait, really? That seems a bit weird. Why would I do it this way? Do I really do a double hit there? Yeah, I do. Well, that's kind of pointless now, isn't it? So let's get rid of you. Did not need that happening in the audio view. And what do we got here? Non-standard game overview. Okay, that's a little awkward. I don't think we need this here either. So we'll go ahead and get rid of that. And we'll just set is listening for submit is equal to true there. Okay, let's go over to here. Same thing, demo end screen. Yep, we're just going to set is listening for submit is equal to true. All right. You know what? Actually, why do I even bother with that? Instead, I can simply move that into the into the open function. Now that I think about it, so let's get rid of you. We're just going to go over here to text west view, and in open, we'll just say is listening for submit is equal to true, and then on close, we'll say is listening for submit is equal to false. Simple as that. Okay, so let's go ahead and close that. We are going to... Oh, I didn't stop playing. Whoopsie. Never do that. You never want to have Unity compile while you're playing. That can give you some weird results. Most of the time it doesn't do anything really terrible. It usually just throws an error at you and says you compiled while I was still running. But sometimes you can get some weird results out of that. Oh, right, color extensions. What to do about this? So let's go to color extensions. Okay, let's see where hex to color is referenced, because we really should use the standard Unity utility one, because that will actually not generate any garbage. Which I guess I can just wrap this for now if I want to do that. So I would just say return color utility dot, I think it's triparse HTML string. Right. So I guess I gotta say bool. Valid is equal to that. And we will need the color. Color out color is equal to color.white. And this is going to be our hex color followed by out color. And we'll return out color. Okay. Pretty simple there. Do I have... Nope, I have color to hex, which is fine. Alright. So we'll just do that. That should also clean up some garbage being generated, because I had some strings that were being compared before. So that should clean up a fair amount of garbage. Well, fair amount is in less than... well, a little over 100 bytes. But, you know, every little bit helps. I wonder why select input Generates garbage. That's kind of weird. Let's see. Select. Oh, it's probably just that then. Select delay. Yep. That's fair. Let's go to what else? Game view open. Really? Game object dot set active is sending. It's because of a bunch of input on enable stuff. That's kind of annoying, but I guess that's understandable. Yeah, it's gonna be a lot of on disable stuff. That is not great. Not a fan of that. Okay, so do we have anything else generating garbage? Nope. So I can't really clean up the on enable and on disable stuff because that's third-party assets doing that. So this is probably the best we can get for our base view code, I think. So we're cleaning up, what, about 40 and 90 bytes? So about 130 bytes total. Well, this one might also, yeah, listen for submit. Okay. Let's go ahead and play again. I'm going to go ahead and clear this. Oh, not current. Clear. There we go. And I'm just going to, we'll put it right about there. We don't need to be in full screen again. All right. I was wondering why we were seeing black even though we were playing. I'm like, uh-oh. Yeah, we still have a bit of a spike here, which I'm assuming has to deal with asynchronous scene loading. It's a little odd that it happens, but what are you going to do? Let's go to extras, author mode, create, Zork. All right. Let's go back here. So right about there, I believe, is where we were. Go back down here so we can see everything a little bit easier. And there we are. So, yep, hex to color now generates 0, and open is still generating some amount of garbage. Well, it's actually a fair amount of garbage. But a lot of that doesn't have to do with me anymore, and we are no longer generating garbage from the actual coroutines that we start whenever we open the field. And I guess I should check that everything actually works still. So let's go ahead and stop playing. We go back. Oh, that's funny. It goes all the way back. That's probably not super great. We're going to try to navigate this with my keys. Okay. Cool. Making sure that this all still works. All right. Take a look at this stuff again. Let's see. Standalone. Huh. Interesting. We got a pretty big spike, but not a ton of garbage generated. Well, that's pretty good. Let's see here. Garbage. No garbage being generated. Well, isn't that nice? Huh. Yeah, we only get 30 bytes of garbage this time, which I guess makes sense because that was the first time the first time was the first time we opened it, and that would generate a fair amount more garbage because it has to instantiate stuff. But we don't have that problem on the second time. So we only get about 3.4 megabytes of garbage generated, which is still not ideal, but I also don't think that we can fix it. So, well, actually, we might be able to. Let's go ahead and see what text quest view update does. Classic mode view on submit. On create clicked. I guess that makes sense. Let's keep drilling down here. Okay, so open generates about 14 kilobytes of garbage, but that has to do with setting everything active again, and we can't really get around that. Okay, wait, hold on. Oh, that's interesting. Set text generates garbage? Huh. Interesting. Let's go ahead and go over here to Classic Games Refresh List, generate buttons, and JSON parser, which is the bulk of that garbage being generated. 3 megabytes of garbage. Oos. Interesting. Read file? That's generating garbage? Really? I was not aware. I would have thought that it actually wouldn't. Okay. That's actually quite a bit of garbage. Um, not ideal. We will keep an eye on that for now. Excuse me. Um, I'm not entirely confident trying to debug the system.io stuff right now, because that stuff can get kind of weird. There are usually really weird workarounds for generating garbage, but I do not know what the best thing to do there would be. Interesting. Parse to array collection generates a ton of garbage. I actually might know why that is. Parse to array. It's this. Okay. Let me do this. So we're gonna say string array value is equal to array. Trim value ends array string value followed by a start char of an open bracket and then an end char of a close bracket, and that should help a little bit with garbage generation, because now instead of generating at minimum probably 2 strings, we're only generating 1 string. I'm also curious if that will throw errors, but we will find out. I'm a little worried that it might not handle empty array stuff, because I know that I need to refactor some of the JSON parser code for the trim function there. All right, once this compiles, and while that's happening, I'm going to take a drink. Still compiling. Jeez. Come on, Unity. All right, let's go ahead and clear this and try it again. A little bit of a lag. It's really weird. All right, so parse to array collection as of last time was generating about 2 megabytes. Let's see what it does this time. I go to extras, author mode, create, Zork. All right. Alrighty then. Routines is actually different from what I was expecting. Do we not want it here? Text West view, update, event system. Like the run behavior update is what I was kind of expecting to happen there, but we don't really get that. Okay, now this is all standalone input module crap that I can't really use. Okay, then let's look for. Well, I guess I'll go ahead and stop playing actually. Let's look for JSON array. Okay, let's look for array. Array.copy. I guess it's going to be JSON parser then. JSON parser. Really? Like nothing? Alright. Here we are. Still about 2.1 megabytes. Okay. Well, but we're getting different calls here, and now we're getting less and less, but that could be because it's further down the line. Let's get rid of this. Alright, there we are. Wow. That really, really slowed things down. Okay, so we have a fair amount of string builders, how to pen stuff going on here. I'm going to try and collapse this stuff so we can get sort of higher up. The more tabs that we have open in the profile view, the slower the Unity editor runs. It's really annoying like that. But we can't really get around that. So it looks like, if I had to guess, it looks like we shaved off about 400 to 500 kilobytes of garbage being generated, which is not a ton, but it is a notable improvement. Because I believe this JSON parser.parse was 3.4 before, and now it's 2.8. So that actually would be 600 kilobytes. So we shaved off a little bit of time there, but we're still kind of lagging here. So that spike gives us about 3 seconds of, well, no, about a third of a second of a lag spike. I'm not entirely sure how much more I can reduce that, honestly, because part of the problem is that it's generating strings and such as we go along. I can't really fix that. Trim value ends will return a string, so there's just going to be that part. Oh, phew, I thought for a second that is null or empty had garbage to it, but it's the JSON array stuff. I'm assuming, yep, that's from the lists. Yep, that's fair. Okay. So yeah, there's not really a lot that I can do to reduce that garbage being generated. 3 MB just seems so much though. Um, Parse that. Parse it again. Yeah. So the string builder.append is understandable, and that's because, well, when we're parsing, we don't know how long we're going to be for that parsing. Still, though, it's certainly much faster than it used to be, although 78,000 calls is not exactly great. What else do we have here that we think we can get rid of? Interesting, we actually are trimming still? That doesn't seem right. Where are you happening? Trim. Ah, I see. Looks like that is where it's happening. Not ideal. That's escaping things. Okay. We will probably have to hold that for now, just because there is some amount of strangeness going on there. And it's probably one of those things that I could find a way around that, but it's probably going to take a while. So we'll come back to that if we run out of other things to optimize. So let's see, we'll keep that tab open for now. We have an object constructor, which is, wow, really? 1.6 kilobytes? Yeah, geez, tons of garbage just by existing. To float, I might be able to get around this. Yep. So we're gonna just drill down until we get to it, right? So there is, I believe, a non-garbage generating conversion function, but I don't know if it will work on strings. Let me check something. You are iConvertible? I might be able to. Maybe. I guess we'll try that. I'm gonna go to my string extensions class. String extensions. Okay. And the main thing is that we want to reduce the garbage generating from converting a string into a int or a float. And let's see, we want to come down here, trim and range, blah, blah, blah. Ah, here we are. So, that's interesting. So it's a little odd because we have, so int and float, and I think bool also have these try parse functions, which will try to parse a string into an integer. If that fails, then so try parse will allow you to fail out without throwing errors. There's another one that's just straight up called parse, and if it does fail, it will throw an exception. But try parse lets you get around that exception by checking for it yourself. But problem is that it seems like that conversion is actually giving us a little bit of garbage. Now there is a way around that by doing, I believe, system.convert dot, let's see, I think it's like two, yeah. So two boolean, or in this case it'd be two int, which is probably going to be 2int32. And then we can give it a value to be converted, which should have a string version right there. And we'll say value. Okay, so I don't know what else we could do there. My format provider, I don't think I really need right now. But this method will allow it to be parsed. The question is if I can detect when it fails, because we need to be able to handle failed strings, basically. I am not entirely sure what to do there because it's going to return an int. Let me look this up real quick. Drag that over. So we're going to type C# convertible. I'm sorry, ibl dot convert. Let's see, iConvertible interface, which should have the actual convert function, and we're going to want a string. Let's see, to. I guess it'd be this. So let's go 2 and 32. Converts the value of this instance to an equivalent 32-bit signed integer. And it doesn't tell me what it's going to do if it doesn't work. Well, that's always great. So let's look for, I guess, convert. I guess it'd actually be convert, not convert. Don't know why I put so much emphasis on the wrong syllable. There we go, system.convert. And we want convert to int 32, just to make sure that this won't throw anything unexpected. Let's see, 2 and 32. Let's do both of these. We'll look at the simpler one by default. 32-bit signed or 0 if value is null. To a number to the number in value, or 0 if value is null. Format exception value does not consist of an optional sign followed by a sequence of digits 0 through 9. Value represents a number that is less than int min value or greater than max value. Okay. Yeah. So that's kind of annoying. It looks like I have to manually catch those exceptions, which is not exactly what I was hoping for. An object that plays culture-specific formatting information, we don't really care about that, I don't think. So, okay. Jeez. We can kind of get around it. I'm trying to think of the best way to do this. Because try-parse generates garbage, and convert should not. But it doesn't have a way of catching it, which means that I have to actually do a straight-up, like, try, and then catch. And I guess I could catch the actual, what is it, like, system dot format exception, I believe is what it was. Let me double check that. It will throw, here we are, format exception, and an overflow exception, which I'm not too worried about. I think format exception would be the big one. So let's go back here. So I mean, I could change this. So instead of doing this bool parsed and all of that, we could simply try converting it. So can we confirm that that was to? It was to float, actually, wasn't it? Let's try that. I'm gonna convert the float call right now. I'm just gonna grab this stuff basically. Get rid of you. Pull this down. We're gonna go to to float, and we will, I guess, do this. So we're gonna grab this. Try convert to float. Oh crap! Really? Really? I thought float was a convertible. Ah, geez, that sucks. So I can convert it to a double. I guess it'd be 2 decimal. Is that right? Nope. Okay. So we can convert it to a double and then to a float, I guess. Ugh. Um, so we would do float. Not really going to do that. Oh, right. I have to assign it in that case. So I'd say float value is equal to that. Get rid of you. Really? String? Oh. Duh. Sorry. I did that wrong. Let's comment you out. This is float value, not value. Okay, there we are. Otherwise, float value is equal to default value. Okay. And we are going to just straight up say return float value. All right, that should, I guess I could actually just say is equal to default value there, and then I don't even need to do anything here. And I think that should work. So let's let that compile, and I guess let's see what happens. Because I'm hopeful that it won't generate garbage this time. And if it doesn't, then yeah, we're going to change all of our extensions to use that system.convert call. Which, if I remember, might be slightly less performant than try parse, but doesn't generate garbage, which is preferable in the long run. So we're going to keep an eye on string extensions.toFloat, or really any of the extensions. Let's go ahead and play. And I think that spike happened when we opened the actual custom adventure that we wanted to edit. So let's see what happens. Click through here, click through here. Oh boy. That lag, let me tell you. Extras. We're going to go to author mode, create, Zork. Okay. Okay. Got about 7 megabytes of garbage being generated now, which is not the best. To float still seems to generate garbage, which is not great because I thought convert was not doing that. Oh crap, I might have to set up an actual iComparable that does something specific. Womp womp. Okay. Yeah, I need an iFormat provider, don't I? I need to remember what I need to do there. I think it's going to be in String Builder. String Builder. Extensions. Let's go over to here. We're going to scroll all the way down to the bottom where we're doing some of this stuff. Let's see. String Builder. We don't need the concat stuff. We want... Let's go up here. Here we are. toInt. So this, I guess, is what we want. Okay. So let's go ahead and grab that. We're going to go back over to here. Can I do you? Why, yes, I can. Well, isn't that nice? Um, arg presumably is, yeah, just an I convertible, which is fine. Value, which is a string. Let's try it there and see if we generate garbage. And if we still do, then I'm going to just get rid of that conversion, and then I'll make a note that I need to clearly look that stuff up again. Make sure that I was not using the wrong theory. Well, while this is compiling, not sure if we're going to get to it today, but if we get through all of the profiling, we will probably take a look at visual scripting again. I think I have a better idea of how we're going to design that. In the past, I tried to kind of overcomplicate it. Well, I didn't try to overcomplicate it. I ended up doing that, and I think the problem was I was trying to allow any node to accept any node, basically, or any input, when instead I really should have more like a node is less of a behavior and more of a state with sub-behaviors. So well, no, not even that. It's like an action. You perform a linear set of actions. So you would do like action A, then action B, then action C. That's probably the way that we're going to go. In the past, what I was trying to do was saying like, you have broad stroke action A, which may involve getting things or setting things, which could cause sub actions, and we probably going to move away from that in favor of a more linear execution of like, you go into the room, what do you want to have happen next? And it's like, well, we're going to set this variable to be this value or increment it by a certain amount or what have you. Let's go to author mode. Let's go to create. Zork. Okay. So we are looking at you. Nope. Okay. Still making garbage. So we will no longer do that then. I wonder if that's specifically a double issue or not. Well, it's fine. In that case, we're just going to do this. All right. And I will make a note while that is compiling that I need to take a look at that. Let's see, programming. I need a new board, or not new board, a new card. And we're going to call this, yeah, we'll call it profiling. Profiling. Let's add a card for garbage optimizations. We will add a checklist. We'll say research. No garbage conversions for strings. Okay. Alrighty then. So where else are we having notable performance hits? Not entirely sure. Oh wow, really? Is it that bad? Woof. This is a really bad lag. So to give you a sense, I am clicking now. So that's like, what, about a second for it to react? Oof. Jeez. I do not know if I'll be able to really clean up the JSON parser very well. At least not live. I get the feeling that's going to be a long and hard process to get it to generate no garbage. So we're not going to worry about that right now, even though it is one of the larger causes of garbage. It will eventually be fixed, but I feel like it's something that would not be very fun to watch on the stream. Because we can't really fix it very fast, since I feel like there's going to be a ton of stuff that has to be set up. Okay, I'm actually curious. I don't think we can get around this on pointer app stuff, can we? I'll take a look real quick. Event button. So event button is a class I made that is meant to largely extend the base Unity UI button class. The main thing is that it just has some extra events. So it has, in addition to things like on click, we have things like on press, on release, on hover enter, on hover exit. So on press is when you press the mouse key or the mouse down. On release is when you release it over the button. Hover enter, hover exit are obviously when you move the cursor or your mouse cursor over or out of the graphic, and so on and so on. But it seems like on pointer up is generating garbage, which is surprising. And presumably, I guess it's actually this. It's just, well, not that, it's this. It's the whole invoke that's happening. Interesting. Oof. Okay then. I think. Jeez. Crap. Well, the easiest thing for me to do is to optimize this with booleans. So I'm guessing that we are going to get garbage every single time we do anything with buttons, with my event buttons at least. Because presumably they are always going to do this on pointer up call here. But it's weird. Well, no, that could be specifically the button, now that I think about it, because on pointer up is actually useful for button transitions. Let's see if it actually goes through our stuff then. Yeah, because it's the selectable, which I don't think, yeah, there it is. I don't think that we can actually do anything about this. This is all graphics stuff. Okay, so I don't need to worry about that for now, which is fine. Go ahead and get rid of all of this stuff, close everything. Execute events. Can't really do much there. That's kind of annoying. Couldn't really optimize that whole chunk of code because it's already at a point where, well, not already, but most of it's at a point where it's out of my hands. It's in like the Unity UI classes. Okay, well, let's see what else we get here. That by far is the largest, which is not great. Player update canvases will render UGUI. Nope, this is all UGUI. Mesh rebuilding, isn't it? Yep. Yep. Can't really do much with that. Harumph. And what about you? Got a fair amount of garbage being generated here. Behavior update, text mesh pro late update, scroll rect late update, which is going to be the thing that needs the most of it. And since it's in scroll rect, I can't really do anything about it. God, this is really annoying. I would like to optimize some of this stuff, but it's either in areas that I can't reach or it's in areas that I need to do more research myself. Canvas stuff, I can't really do anything with that. Yeah, that's really annoying. Go back up here. Send mouse events. This is going to be the same thing, isn't it? Yep. All right. Man, I keep yawning. Clearly, I should have taken a nap today. Player update canvas, can't really do anything there. Camera render. Audio spline, that's an editor overhead, I'm assuming, so that's nothing I can really do. 72 bytes, we're not going to get much out of that. And it's in Text Mesh Pro input field, so I can't even do anything with it. I bet that's coroutine. Yep, it's coroutine. Okay. Annoying. Well, can't really do much there, so let's go ahead and move this stuff back up for now, and I'm gonna do a quick run through of like the map. So we're gonna go to the custom adventure, we're gonna go take a look at our map, move some nodes around, see where garbage is being generated, and try to patch that up. Start, extras, author mode, go to create, Zork. Man, we really got to fix that. A little bit of lag though at the beginning. It's a really bad lag spike. Let's go to the map. this around, move this around. Okay, so here's the map generation. Whoa, 14 megabytes. Dollars to donuts. It's the JSON parser. It's always going to be the JSON parser. It's always going to be there. Just let me drill down to it. I know it's there. I just want to confirm. All the way. Okay. Let's see here. Custom game author session. There's the 2JSON. Ah, jeez, really? Generating about 200 kilobytes of garbage every time we save. Woof. That's not great. I really don't like that. Also interesting, JSON object.setValue. Oh, I guess it was calling add. Okay. Yeah. Yep. Not a ton that I can do there. GameView.close. Set active. That's going to be more on enable and on disable calls. A little annoying. Let's go to custom game session, 2JSON, item 2JSON, interactive object dot 2JSON, room info dot 2JSON. Yeah, we can't really do much there, can we? Color dot 2string. Oh, that's interesting. Huh! I was not aware of that. Okay, apparently calling Unity's internal color class .toString calls string.format. Okay. Huh. I wonder if we could actually optimize that and build our own string, like, builder for it. That would be interesting. I think we might actually be able to come up with a better thing, or a better way of doing this. Presumably, a lot of that garbage is coming from formatting. Because colors are rendered out in float values from 0 to 1. So a color with a value of 111 is white, and the color of 000 is black. And presumably here what's happening is they chose to, instead of use a string builder, to just have a constant string, I'm assuming, and then they just use string.format on that to give it the values that it needs. But we might be able to get around that by using a string builder. I'm actually kind of curious about this. So we're going to do a little bit of a debug test. Okay, we don't usually do this, or rather, I don't usually do this. I'm going to create an actual test scene for this because I'm kind of curious. Okay, so we're going to go ahead and make a new scene. We will. How do we want to handle this? We will. Trying to think of how to structure this. We're gonna need to keep track. I guess we'll just profile it. That would be the easiest thing to do. So I'm gonna make a test class here. Go ahead and get rid of you. Let's go down here to test. All right, I'm gonna create a new C# script, and I'm just gonna call this color test. Okay. Open that up. So what we're going to do here is we're going to run a test to see if we can create a color.toString function that's better than Unity's internal color.toString, or at the very least generates less garbage than it. I'm kind of curious to see what ends up happening there. So first up, we're going to have an enum that we start with, and that's going to be method. It's going to be a byte, and it will be Unity is equal to 0, custom is equal to 1, and then we're going to say serialization serialize field, private method, method is equal to method.unity. So that means that by default we will use Unity's string method, or toString method, and we'll say private color, we'll just say color is equal to color.white. Okay, and we're also going to need to say using system.text. We will also actually go ahead and serialize a field, and we'll say private int test count is equal to 100,000. That seems like a good thing. Basically, what we're going to do is we're going to iterate through. We'll do 10,000 actually by default. Maybe 1,000 by default. And we're just going to do a for loop and say we're going to call toString on this color. So we will say private void update if input.getKey down. We'll just say spacebar for now. Keycode.space. All right. Then we're going to say, come up here, private void test. Okay. We'll call test here. And we're going to say, we'll do switch. We'll just do an if statement. If method is equal to method.unity, then we're going to do that. Otherwise, we will call. Okay. So we're going to do a for int I equals 0. I is less than test count I plus plus. We're just going to say color.toString. Okay. And otherwise, we are going to do for int I equals 0. I is less than test count I plus plus. And we're going to say, I guess it would be string builder color string is equal to new string builder, and then we'll say color string. I guess it would start with this, right? Oh, you know what? I guess I probably should go ahead and do a test. So I'm going to say private void start. Make sure that I debug the correct thing. So in start, I'm just going to say debug.log color.toString. I want to make sure that I format it correctly, so I'm going to go ahead and run that real quick. Pretty sure that it's just open parenthesis, then the R, comma, G, comma, B, comma, alpha, and close parenthesis. Pretty sure that's all it is. But, you know, it's good to be sure. Ugh, I hate it when it does that, though. Let's go ahead and close that, just so that I can freaking fix it by double-clicking on it here. And I won't actually save that yet, because I want to add it in here, and I just want to see what that output is. Okay, so let's hit play. We should get a string on start, and then we can stop and save that. As soon as Unity feels like it, I guess. All right, there we go. It's got RGBA in front of it, so we need that too. All right, that's perfectly fair. So we are going to come over here, and we will say, I bet actually that's probably why it's so messed up now that I think about it. That's interesting. So we're going to come down here. We're going to say string builder is going to be equal to that. And its capacity, if we want it to match exactly, should be, I guess, so that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Kind of lost that. Dang it, let's count. Well, the easy way to do that will be to simply copy this and paste it in and then count it. Okay, so it's going to be equal to that. That's what we want. So we want 4, so that's 5, plus 1, 2, 3, 4, 5, so that's 5. So that's 5 plus 7 plus 7. So it's 14, 19. Well, no, let's go. So that's 10 plus 14, so 24. 20. That would be 31. 32. So I can simply say 32 because that's going to be its capacity. And then I guess we would say color string dot toString at the end of this. All right. Now, for the rest of this, we're going to want to say color string dot append, and we'll start with this string, which is going to be RGBA open, and then of course we'll end with color string dot append. It's going to be a close char of that. Okay. Then after that, it gets a little bit more crazy. So we're going to want to say color string. Wow, that was terrible. Color string dot append, and then color dot r. Color string dot append, a comma, then a space. Color string dot append, color dot g. Oh, this is right, a string, not a char, so I have to do that. Let's go ahead and copy that, and we'll paste this as b. No, and I actually needed just copy this. More alpha. Okay. I think that's what we want, so we'll see if that's more intense. It actually might be because we have so many string builders that we would have to instantiate, but we will see. All right, I'm gonna turn on the profiler here. Of course, it's gonna take forever for it to compile, so I'm gonna take a drink instead. All right, let's go ahead and clear this. Cool. And we're just gonna play. Make sure that everything is correct. Let's make this red. Make it a little bit easier. Okay. So this is going to be interesting. By default, we will be using Unity's built-in toString method, so we'll be able to see that overhead. And make sure that that's the case. Let's test that. So that has us at about 0.7 megabytes of garbage. Convert over to custom. Boom! Yeah. Sweet. Although we do have a question now, I'm kind of curious. Which is more performant in terms of time? Oh, it's also faster. Okay. Okay. Really? Huh. Yeah, it's about like 2/3 as expensive. Well, it's a little over half the amount of time to execute, and a little over 2/3 as expensive in terms of garbage being generated. Well, that's actually pretty nice. Although interesting, most of it comes from stringbuilder.append. Oh. Because it's converting. Can we get even lower then? Oh, we might be able to. No, I think this might be doing internal conversions that, yeah, we probably can't actually do that. Okay, but it's still better and faster. Okay. There's got to be a downside to this, right? Like, surely there is a downside to this. I don't know what it is, because it seems to just be better all around. Well, then again, self milliseconds for our custom one is 1.32 milliseconds, and for theirs it's 0.12. But then immediately below that we get color.toString, which is 1.32. 0.39 versus, well, okay. I'm wondering then. The self milliseconds is kind of awkward. But I don't actually know what that is, now that I think about it. Go ahead and stop playing. Oops. Almost knocked over my water bottle. Enough that it did affect my monitor. Okay, let me see here. So I'm going to look that up real quick. The profiler self milliseconds. I actually don't know what that does, or what that is. The self column refers to the amount of time spent in a particular function, not including the time spent calling sub-functions. Screenshot above, 41.1% of the time is spent in the camera render. Oh, that's something else. Is that? Hold on. There we are. Okay. I was wondering about this. So this is our custom one, and this is our built-in one. It's still not really giving me a ton of content. Although our custom one does take up percentage-wise less of the CPU, so that's great. What we got going on here? Although, wow, self is really... the self millisecond is the only one that's noticeably larger. Time millisecond and self millisecond columns show the same information, but in milliseconds. Wait, what? Okay. But including the functions it calls, 0.21 milliseconds are consumed. Okay, I get it now. So that self millisecond is kind of it's specific to how much or how many milliseconds that function itself calls, which makes sense that we would have a larger call in our custom function, because our custom function is doing what Unity's internal stuff is doing in addition to the function itself. So Unity's internal toString color call is more expensive. It just looks like it's cheaper on the self side because it's not doing a bunch of stuff by itself. It farms that out to an internal function. That makes sense. Okay, so that's why color test is smaller there, and that's why toString is larger there, because it's doing a bunch of stuff like that. Okay, yeah, makes way more sense. I gotcha. So yeah, I don't really know why we wouldn't do that. I guess we'll run one more quick test, which is going to be, you know what, I'm just going to do this. We're going to change method here to up here to test. We're going to call that method. Okay. And then we are going to have keys that we assign here. So we'll say serialize field, private key code, default key is equal to, we'll say key code dot u, then serialize field, private key code, custom key is equal to key code dot, we'll just do space for that one. All right, and we're going to say if we get custom key down, then we're going to go ahead and test method dot custom, else if input dot get key down, not custom key, default key, then we will say test method dot unity. Okay, so that'll let us toggle through that a little bit faster. And is there anything else that I want to do there? I don't think so. I think we're doing a good job with our string builder here. I'm a little concerned. I'm actually going to add some extra parameters here so I can debug this a little bit better. So So we're going to go ahead and say serialize field private bool debug is equal to, well, we'll say log output false. Okay. And after this, we'll say if log output debug dot log color dot toString. Dang it, because I need to do this whole thing again, don't I? So if, oh dear, that's not at all what I wanted to do there. Okay, there we go. So I'm going to say if log output. Okay. So that will be a little bit better of a test now, especially because we'll be able to convert, well, not convert, we'll be able to observe if, oh, I was still playing, because of course I was. Because I get stuff like that, where it lags out, and therefore it doesn't want to stop playing. Does it not tint at all? Oh, it does. It's just really subtle. I really should change that so it's way more obvious. Okay. I got you, Unity. Okay. Let's clear that. And we're just going to go ahead and give this a try. See what happens. We're also going to bump the test count up to 10,000. Okay, so we're going to try U. Oh boy, 7 megabytes. So let's try this again. I'm going to try U, and then a space. So we get, oh, dang it. Of course, I forgot to debug that anyway. Debug.log. Log that, and of course, I also need to set my log output to be true, so I can compare these two. Because I think what's going to happen right now is that my version of the toString for color does not actually guarantee that we will get 3 decimal places. So that's a little annoying. I could actually get around that with some quick checks. And let's actually make this a weird color too. So let's go for something like 274. Let's do something like that, I think. Kind of like an azure-ish. Because that'll give us a good blend of colors. And I want to see if it still formats to only 3 decimal places. Let's go ahead and save this. There's no reason for me to save this as a test scene. Okay. Clear U. Everything's good here. Let's take a look at this. Okay. So this time, crap. I do want to increase it to 10,000 again. So 10,000. So it's going to run 10,000 times, and that will give us a good check. So I'm going to say start with U, end with space. All right. Yeah. So our version of the string, or of the toString call, does clamp the single digit numerals. So if it's 1.0, then it's just going to be 1 instead of 1.0. So if we want those extra values, we need to append them ourselves. So yeah, that is a little trickier, but I think we can handle that. So I'm going to go ahead and try something real quick to make sure that it looks the same. So we need to, I'm going to go ahead and get rid of this real quick. I guess we would also want this to be a function that I call. So let's go ahead and do a private. Okay, we'll try that. Can I do static? We'll do it. Static string color to string. This color is going to be that. I'm just going to take this, grab that. Color string is equal to that, and we will return that. That color is good. Okay, so I'm going to get rid of this, and we're just going to call color to. Dang it! I can't do it, can I? Wait, why will you not work? I have this, don't I? This color. Private static void. Is it because it's not public? It might have to be public. That'd be interesting. Really? I'm just gonna be mean about it. Huh. Excuse me. Well, why would you be different? Let's see, static color, hex to color, static invert. Yeah, that's all it is public static, and then some return value, and then this color. But that doesn't seem to want to happen. Color dot. Can I do this instead then? What the heck? So why? Interesting. I'm gonna go ahead and save this. I have a theory. This would be interesting if it proves to be true. Ah, okay, that's why. So we're gonna, I guess, go ahead and put this into our color extensions class. I didn't realize that it had to be in a static class. That makes sense. I just didn't think about it. Okay, for now, I guess, and it's gonna have to be in here anyway. Using system.text. Okay, let's go ahead, go up here, get rid of this. I'm gonna say debug color.toColorString. Okay, and then if log output debug.log color.toColorString. Okay, so let's try that. See what it does. Oh, except that didn't actually do anything yet. I need to go back to color extensions. I need to run some tests here. So we have to separate these values, and alpha also needs to be 1.0, doesn't it? Okay. So basically after, actually that was the wrong place to put those. After every color is appended, we have to do a length check. Oh, dang it. Will capacity and length be the same? We'll find out. So we're going to say if color string dot length is less than, let's see, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If it's less than 10, then we need to append zeros, basically. So we're going to say for int I equals 0, I is less than, you know what, I'm wondering if this will be the thing that actually makes our garbage get generated. So it's on par. That would suck. Actually, no. I can do even better than that. All right. Let me think. I can actually get away with having a static array for this, can't I? So I'm going to say private static string color string decimals is equal to new string array of 3, and it's going to be one of these things. It's going to be 0, 0, 0, or 0, 0. Okay. It can only be one of those three. And we are going to want to say, right about here, so we're going to want to say int index is equal to 10 minus color string dot length. Okay, so if it's yes, I think that's what we want. Actually, you know what? Here, we're gonna have to debug this. So I'm gonna say debug.log color string.length, and we're gonna debug that at key points here. So we'll say R, copy this, paste this down, G, B, and then A. Okay. So I'm going to run that. I'm going to reduce our numbers of tests to 1 because I don't want it to debug that 10,000 times. If this still generates less garbage than Unity's internal allocations, I am going to be, 1, surprised, and 2, I guess I will start swapping my stuff over to use a custom to string, and then I'm going to have to talk about this. That's interesting. I kind of wonder what Unity's internal toString calls are now for colors, and actually some of their other stuff. Let's go ahead and clear this. Because there has to be a reason that my current system generates less garbage. It'd be weird if it was just a... My assumption is that it's just something that someone threw together at Unity and they never bothered to really optimize it. But typically, what's likely to happen there is... Yes. Okay. And that's correct. So 17, and then after... so we'd be good after G, but after... yeah, so we're good up to G, but after we get to blue, we start getting shorter and shorter. So we need to make sure that we get good values there. Okay, let's go ahead and step plain. So I do need to do string checks here, well, length checks here. And then I want to say, if it's less than 10, which means that it's not using the full 0 decimal places, then we need to subtract 10, or subtract the length of the color string minus, or from 10. So if the length of that color string is 9, which means that it's missing 1 0, then we're going to get an index of 1, which actually means I probably want to just go ahead and bump that up to 11 minus that. I'm sorry, that's completely wrong. It's going to be 9 minus that. And then we're just going to say color string dot append, and that would be color string decimals of index, or idnex, if you're me, I guess. Okay, so that should append a string, and since it's a string, we won't get any conversion costs. So let's copy this, and we're going to need this value to change every time. So we will keep, I'll keep the debugs here, mostly because I'm kind of curious to see what they, make sure that everything ends up looking correct. So we're going to grab this if I can grab it. I guess we'll also shrink this down, so I'll make it as short as possible. We're going to go to here, we're going to go to here, and then we're going to go to here. All right. And from there, we are going to want to say if color string is less than, so we're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 for you. I think that means 16 there. Then 18, 19, 20, 21, 2, 3, 4. So 24 is the next one. 3. Then 5, 6, 7, 8, 9, 10, 31. Which makes sense, because that would be 32. Okay, so 31 and 30. Let's see if that gives us what we want. I have a good feeling about this. And if it works, I will be very, very happy. And also kind of excited. And then, of course, I'm going to have to like dig into the Unity DLLs just to make sure that they're not doing something really cool that would prevent, I don't know, weird errors from happening. Okay, let's go ahead and clear that. We will clear you. And we'll run this. We'll run it once again, just so that I can see what my output is. Make sure that that seems right. Okay. I probably should have also set my alpha to be like 200 instead of 255. So we're going to say space. I was worried about that. 20. Blue was 20? That was interesting. G was 17. Okay. This is interesting. So 23 minus... No, that's right then. Did I miscount? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 21, 2, 3, 4. No, that's right. 24. Okay. But that's clearly not right. Because... Oh! Decimal. I forgot the decimal. Right. Okay. Yeah, that's not good. Okay, crap. So I need to handle what happens when we don't have any decimal places. Hello, Anthony. Welcome back. How are you doing today? We are currently working on an optimized version of Unity's built-in color.toString function. Because their function generates a ton of garbage compared to the current system that we're messing around with. So, how to handle this? I mean, I could do like an index of. Would that be fine? Let's see. Color string dot. Well, not that. Color string dot. It doesn't have that. Crap. Do we have like a find? I'm wondering if I can get that. End, insert, number, length, find, string. Nope. Hooray. Crap. We don't have that. Well, we're going to add that, I guess. So let's see. Trim. I'm just going to put this up at the top because that's actually kind of a nicer thing. So I'm going to say public static string. Oh, not string builder. Int. Index of this. Not that. This string builder. String builder. We'll call that value. Oh, and then char. Char. That's terrible naming. I'm gonna call that cha for now. Mostly because I'm curious. What's the actual list function look like? I have a list here. Okay, list string t dot index of item. Okay, I was wondering what the parameter was called. Let's go up to here. This is going to be item. So we'll look for a char, and we'll just say for int I equals 0, I is less than value dot length, I guess, I plus plus. And we'll say if if value of I is equal to item, then we will say return I. Else, what am I doing else for? Return -1. Okay. So we have. So I don't handle chars, but I won't handle things like ints, and we kind of want that. We don't actually need it for what we're doing right now, but I would like it. I'm a little concerned, though, that I can't really get that anywhere. Well, no. Because this is going to be a char, isn't it? It's got to be. Come on. You can do. Ah! Yeah, that's fine. Okay. We'll just do this char for now. So I'm going to come over here to color extensions, and I guess I'm going to say if color string dot index of that dot is less than crap. Now I need a last two. Back to the string builder extensions. So we're going to say public static int last index of this. Stop that. This string builder value char item. Okay. Then we're going to do pretty much the same thing, but in reverse. So we're going to say for int I equals value dot length -1. I is greater than or equal to 0. I minus minus. Then we'll return -1 if nothing's there. And then we're just going to say if value of I is equal to item, return I. Okay, let's go back over to color extensions. So I'm going to say if color string dot last index of that char, and so if that's less than 21, I believe, then we're going to need to append it. So I'm going to say color string. Wow, that was terrible. We'll say color. Hold on, gotta organize this code a little bit. So we're going to say color string dot append. We're going to append a dot. And then we're also going to say index minus minus. So we'll subtract 1 from the index. And that should work. So let's go ahead and grab this. We're going to need to have that for our green and our red as well. Put that there. And as well as we'll also need it for our alpha. So that's going to be this -3 for that value that we need. So that'd be 14 here. It's a little annoying to work with magic numbers here, but it's understandable at the very least. So there's going to be 7, and then we're going to paste this down here, and it will be 28. So let's try that debug, and hopefully things will work. Yeah, maybe. Yeah, I'm pretty confident that that will work. Okay, we'll find out momentarily. Any day now. Any day now. Shazam. Haha, that was the magic word. All right, try this again. Do not know what that initial pause delay or play delay is. That's kind of weird. All right. What are we looking at? What are we looking at? What are we looking at? Huh. wait. 133. I mean, it comes out right, but now I'm worried about that. Ooh, yeah. That's not good. Okay. Yep. Wow. Mine is way more expensive if we're doing the formatting. Oh boy. Yep. 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 Their internal two-string call is 1.5 kilobytes, and mine is now 120. So that's not great. I'm actually curious to know why. Oh, we're also getting some false positives. Okay. I guess we're gonna get rid of these debugs because that is throwing off our results. Okay, I think we're good there. And actually, can I do an incapacity and a value? Oh, good, I can. Well, we're gonna just slide that right in there. Zoop. And then we can get rid of a whole append call. Okay. So that should now help bring things down because we no longer have debug calls going on there. So that'll give us a more valid test result. I also don't need details here. All right. So that does not inspire confidence, though. That was a ton of string builder.appends going on, and it does seem like most of that came out of debug, to be fair, but it still looks like we're getting 0.6 kilobytes about. Really? A string.concat, too? That's interesting. Where are you coming from? Oh, it's because it's from the debug. Okay, so that might have all just been debug calls, actually, now that I think about it. Let's go ahead and clear this and try it again. Any day now, Unity. All right. So there's Unity's, there's ours. They're close, but I think mine's still faster. Two string is 1.5 kilobytes. Ours is, well, why are you so freaking? Well, ours is still better. 13.8 versus 13.2. Okay. What is this? Color extensions? Is that a constructor? Hold on. Let me run this. Let's keep running this. So Unity's and ours. Okay, we might have had some extra overhead actually from. Yeah, we did. From our color extensions class being constructed. So we're running. It's not quite as dramatic, but we are running about 1 kilobyte of, well, no, about 0.5 kilobytes of garbage faster. It's also actually significantly less, half a second, half a millisecond. Yeah, about 0.5, about 0.7 milliseconds faster. Okay. So color.toString is 1.5 kilobytes. ToColorString is 0.9 kilobytes, and most of our slowdown is from debug. Okay. So stringbuilder.append is generating a fair amount of garbage. Stringbuilder constructor does generate a fair amount of garbage. We can't really get around that. Stringbuilder.append, single.toString, string.char copy. So, we might. Yeah, we might be able to do some more convert wizardry to get around that. But as of right now, that's already about 0.5 kilobytes of garbage better. Well, 0.7, right? So 0.9 and yeah, so about 0.6 kilobytes better. So that's interesting, and we get pretty much the same results. So that's the Unity built-in one, I believe. Okay, apparently you don't want to highlight it, I guess. What the heck? There. So that's the Unity built-in one, and this is our custom one. They are, as far as I can tell, identical. I am going to. I guess we should actually have. Let's test white to see what it does. So let's go to just full on white, because that should be one. That should be 1111, and that means that we will have all of our zeros being appended. So let's try this again. We're going to say U and space. I still think we're slightly better. So about 1.5 versus still about 0.9. Okay. So we're doing good. We have a better .to string. And they still look the same. They do indeed. All right. Let's go ahead and make them all kinds of weird. So let's go like... Okay. U and space. So when it's like that, it's 1.5 kilobytes versus still 0.9. Okay. Well, then I think we're probably about as optimized as we can get there. Everything looks the same. Yep, looks nice. I really want to try to get to like a weird state where it's like 0.2, so that we can make sure that all of these are getting incremented correctly. I don't know what good values would be there. I feel like 25 would probably be decent. Let's try that. So let's go for like 25, just to see what that looks like. Because I want to make sure. Uh-oh. That is what I was afraid of. Wait, what the heck happened here? Why did our comma not get appended? Okay, so we're going to want to save this color. I'm going to grab you. I'm going to stop playing. I'm going to paste you back in there. So our red got borked there. We were correct up through red, and then we got 03922. What the heck? Where did that number come from? Because everything else matches up. What the heck? Where did that number come from? 03922. Oh, I get it. That is the real value. That's why. Okay. I'm actually curious. Let's go ahead and I'm gonna play this again. I want to see what happens now. I'm curious to know if our function will run slower if we have to allocate more space for our string builder. There's Unity's and there's ours. Okay, so color to string is still 1.5. We're still slightly faster at 1.3. And milliseconds, 0.3. Okay. Time in milliseconds really went up. But did it? 0.34. It did. But it's weird because we're faster overall. Okay. Oh, geez. Yeah. So it's giving us more. Ugh. So I'm assuming that extra overhead that brings us to 1.3 is because of this. Where is it? It's going to be every time we call append. There it is. The internal.ensure capacity is going to get called. Uh, Not ideal. But we still run faster. So let's go ahead and stop this. We're going to change our test count to 10,000. Yeah, we'll make it 100,000. Why not? We're going to try this again. Keep habitually saving. Okay, so we should get probably a couple megabytes worth of garbage from Unity's internal.toString. Go ahead and try this. So there's that. Oh boy. Woo! Oh wow, it's so big that we get a floating point precision error. Okay. Can't really do that, so I guess we'll lower you to 10,000. Okay. Try that again. Phew. Oh boy. That is a huge percentage of itself. But at least it only has one call. Alright, so we're going to say U and space. Alright. So at U, we have roughly 7.1 megabytes of garbage. And with custom, we have 6.3. Slightly faster, slightly less garbage. Yeah, I mean, it seems like, from what I can tell, we're just better overall. Call to test here. The self milliseconds always throws me off. They're slightly faster, but why? That's kind of weird. Well, okay then. Oh, maybe it's because it has to do this internal comparison. That's probably fine. So it's about, in total, time milliseconds spent. Our custom one is 351 milliseconds. Unity's built-in one is 528 milliseconds. Unity's internal toString also generates about 7.1 megabytes of garbage, while ours only generates 3.6. I'm sorry, 6.3. So that's better. I mean, it's slightly better. And if we convert this to like solid red, I'm pretty sure we get a really nice boost over them. So let's go ahead and try that out. Type U space. Okay, so again, I think Unity has a flat rate. No matter what it does, it's always going to give you the same output. So it's going to eat the same amount of resources, although its time millisecond was improved a little bit. And yep, I was right. So if we are formatting something that is less than or only those three characters, well, maximum of 5 characters that a color can be by default, then we are much faster. So let's go ahead and debug that. So yeah, something like this, we get much better. We're more accurate, and we are faster actually. So this is better. There has to be a reason why Unity doesn't do it like that. Because we are generating objectively less garbage, taking up less time, and just running better. So that's interesting. Okay then. Well, I will take it, I guess. So pretty much anywhere where I'm calling color.toString. That's going to really make things hard for me, because now I don't know where color.toString is being called. Ugh. I wish I could search for references in relation to just color.toString. Maybe I can. I'm going to go to color real quick. Go to definition. So this is inside of a Unity DLL. Okay, I've never seen that pop up before. There should be a toString here. Can we actually see what it's doing? No. Let's see if we can find all references to this specifically. I'm a little worried that it's going to give me all toString calls, in which case it's worthless. It probably has a lot. So that search will probably take a little bit. Um, can we let you go while I look at my color extensions? We can. Okay. Well, let's can't really do much here, so I'm gonna just kind of move this down so we can see as much as possible. Ah, here we are. And how? Oh, yeah, yeah. It's all two strings. Oi. Um, Does it go to implementations then? Okay. I thought there was a way to search for something for a method that was not including its base method calls, but I guess not. Yeah, this would by far be way too cumbersome. Oh wait, no. Ah, yeah, everything's assemblied. So all I need to do is just use the assemblies that are mine. Okay. So we don't need you. We don't need you or you. We don't need you. You. Oh, and it also is going to give us our what's calling two strings, so that's actually fairly useful. I'm gonna go ahead and collapse all of the editor or all of the DLLs that we don't need or assemblies that we don't need. All of this. All of you. Okay. So all we need right now are these ones. Oh, that's the assembly one, so I don't actually even need this one. I just need Sleepy Owl and Sleepy Owl.textQuest. And I guess they're editors. Okay. So let's see here. Float to string, into string, based on bool to string, not our cares, XML data. Huh, wow, didn't really do any color to strings in common. Bools, int string builder. Okay, apparently nothing in our common. That's seemingly unlikely. Okay, there we are. Color.toString. Oh, nice. It even sorts them so they're not spread out. That makes things way easier. Let's go ahead and collapse everything so I can get them all. We only really care about that, not vector 2. I also bet, though, that I can get a faster vector 2 and vector 3 to string, and probably a vector 4 to string, because color is basically just a vector 4. Get rid of you. There's our color to string. SP. What am I doing in there? SP color? Spawn point window? Oh, yeah, okay. Forgot about that. Okay, yeah, that's actually not that bad. Cool, so I don't have too many that's going to optimize, but hey, take what you can get. Let's see, custom game settings. We will go ahead and we'll say to color string. To color string. To color string. Color string and to color string. Let's see, that's all in to color string. Go ahead and save this. To color string. To color string. Color string. All going to be in the same spot, fortunately. Okay. These are all going to be to color string. Nice. Cool. So saved a fair amount of garbage being generated there. Actually, if that was enough, that means that whenever room info is being parsed, we might have actually saved a couple of megabytes. Now that I think, well, no, that's probably a bit much. We probably saved a couple of kilobytes, maybe several dozen kilobytes. Because obviously, keep in mind that our tests that we were running here were with 10,000 calls, and that it took 10,000 calls for us to get 2 megabytes worth of garbage difference. So we're probably only running, I don't know, maybe 10 times, which means we're getting 1,000 times less than that difference. So that'd be 2 kilobytes. We saved 2 kilobytes with all that work. Okay. And now that probably answers my question as to why Unity didn't do this, because it's really not that much of a difference. Although our time in milliseconds is about 200 milliseconds, is that right? No, it's about 100. So that means reducing that by a factor of 1,000, we're really only saving about 0.3 or 0.1 milliseconds, which is it's a chunk of time. But yeah, it's not really gonna save us a lot in the long run, I guess. So okay. Yeah, but now it gets kind of awkward because, well, no. We'll leave that as is, I think. Alright. Let's go ahead and go back to the main scene. Scenes, other, splash fade. Alrighty then. Wrong thing. Oh, it didn't load. There we go. Don't save. Because we do not care. And I'm actually going to go ahead and close my color test and get rid of these things. And then get rid of my test script. Okay. So, with that little, and I guess I do mean little optimization, because we'll probably only save about 2 kilobytes, if that. That optimization, I'm not entirely sure what else we can optimize. For the most part, I think we're running a pretty good tight ship on garbage generation at this point. Not really sure what else we can optimize besides the JSON parser. Obviously, it's pretty monstrous. But it gets tough to really figure out how to optimize that, because it's really dealing with strings, and it's dealing with non-strings too. So you're just going to get garbage from that. I mean, we could try as hard as we want, but there's a limit on what I can do when dealing with strings and conversions. Okay, so we're going to click through here. Start. Let's go to extras. We will also do this. Okay, I was going to say, where's my background? Author mode. Create. Let's go to Zork. Okay, so there's our 2 big spikes. I'm going to come back here. Take a look at these. Woof. So when we open the map, we get 14 megabytes of garbage. A lot of which is still JSON parser related. Let's see here. roominfo.toJSON, JSON object.add, JSON number, string. I'm kind of curious. Yeah, oof. It actually seems like a lot of our JSON stuff comes from the fact that we don't know how large our list of values is going to get. And a lot of the garbage being generated is being generated when it has to reallocate more space, more memory to that list. not sure how we can get around that. I mean, the obvious way would be to know exactly how many elements we're going to have, but that's kind of tough to do. Um, it's not impossible. It just means we would have to think things through a little bit more. Um, and really, we could only do it in a partial manner. Like we could get the base amount normally that we would expect for so for things like item.2json and interactive object.2json, that's actually a fairly I don't want to say easy, but it's a fairly predictable amount of capacity that we're going to need for each JSON object, because we know the base fields that will go into that. We know the number of verbs that we have, for example, and all of that. It just gets tricky beyond it's just kind of awkward beyond that. Well, no, we would always know how many outputs we have and such. So yeah, we could do that. It would just be a fairly massive overhaul for not a ton of gain, honestly. Let's see, what do we got here? Interactive object. Oh, stop that. I hate it when it does that. Yeah, well, we're probably just gonna skip over the JSON stuff again because it would be like a even longer version of that color conversion that we were just doing. So, let's see here. Where else do we have besides 2JSON coming out? Vector2.toString. Where'd my color.toStrings go? They're gone. It's weird. So don't know what's up with that. Excuse me. Connection group. ToString base info 2JSON. Now it's just going to be more of that. Again, don't really want to focus too much on the 2JSON stuff because I don't think we can really get around that too much. Okay, let's see what our open does. Refresh map. Custom game session load game data. It's probably not great. Load background images. Well, it was the first time, so that makes sense. Yeah, we're going to get a lot of... Yeah, that all makes sense. Not a lot I can do there. Because we're loading in images off disk and turning those into sprites in the background, and that's pretty memory intensive. Generate connections are 9.9 megabytes of garbage. Custom game author session save custom game is really 3.2 megabytes. Jeez. Two formatted string. That's where all that garbage comes from, huh? Ugh. Yeah, that's a lot. But that's also understandable, I guess. Not ideal. Okay, let's see here. Save custom, we're going to skip that. Custom game map view, string format, manager.request. That's going to be instantiating stuff. Add connection? Really? Oh, no freaking way. Oof. Well, that's kind of redundant, isn't it? So on add connection, let's go ahead and pull that script up, actually. Custom game author session. Let's close this. We want to look for add connection. So, interesting. Is loading has to be false then? Or has to be... Yeah, is loading must be false. Because you'll notice that we got like a nested call here to save custom... Oh, freaking... So we add a connection. Slightly accidentally click on it again, and that just jumps you all the way up to the top. So we generate content which adds connections to the custom game author session, which seems to call save custom game. Yep. But that shouldn't happen because we're currently loading stuff from it. We're not actually doing anything with it, which means that is loading is okay. That makes sense. Is loading would be false because we've already loaded. Okay. Okay. So we're gonna change that. We're gonna go ahead and find all references here. We're gonna change this to pass in a bool, basically, because the problem is that whenever we generate connections, oh frack, right, this is not great. That might be irrelevant then. No, that's not irrelevant because it's saving whenever I load in. Yeah, so the approach that we took before, and this is the reason why it's kind of problematic, is we basically, whenever we create a new connection, all we really do is call regenerate connections. So we regenerate everything on the map, and that is problematic because that system had us basically assume that if a connection doesn't exist, then we want to add it, and therefore call save after we add it. But the problem is that when we are when we're loading, when we're generating those connections, custom game author session is going to save every single time that we create a connection. That's like while they're being generated. That's the problem. Yeah, that's not okay. Jeez. Yeah, okay. Jeez, how do we want to handle this? So, in our custom game map view, what should happen when we click on a node, let's go down here. There should be an on node clicked. On legend click on stats clicked. On connection cleared. On node clicked. We're going to open, and what should happen, let's go to here. Gotta remember exactly where we call this, but basically whenever we change our exits, those create transitions or connections, and once those are created in data, they get refreshed and regenerated as physical objects in the scene that you can see and interact with. But that all happens when you close this menu, which goes to refresh map. I guess, jeez, info clicked, which is going to do a bunch of stuff. Let's go to the info menu, peak definition, go to definition here because this should have information on all of our exit areas. Background, exit grid, new exit button. Yep. Let's go to that real quick. New exit clicked, go to definition. Current room.exits. Okay, so we add that to the current room, which is in our main data. So that just gets pulled by the map view. And, geez, that is all kinds of roundabout. And then what happens is when we come back here and we call refresh map, which is here, we clear all of our nodes and we clear all of our connections and then regenerate them. And that really is problematic. Jeez. Okay. So we might need, one, to pay attention to my cat because she wants attention. Yes, I see you, cat. And two, geez, this is a bit of a mess. I guess what we could do is just not save whenever we add or remove a connection. Because So what we would do is instead of saving here, so let's get rid of that. And instead of saving here, cat, yes, I see you. You do not need to get on my keyboard. So instead of saving whenever we create or destroy a connection, instead what we'll do is in custom game map view, after we refresh the map, we'll do that. So it's completely irrelevant. Okay, there we go. Let's try that. So that was a completely redundant thing that I was doing. That was generating 9.5 megabytes of garbage. Well, let's see what happens now. I'm kind of curious. So before it was generating, the function generate connections was creating about 9.9 megabytes of garbage. If we're lucky, and if I'm right, that number will drop by 9.5 megabytes. Let's find out. Because that is definitely a good optimization, and will go quite a long ways towards saving garbage. Or not generating garbage, I guess. Okay. Go ahead and say start. We're going to go to extras, then to author mode, create, Zork. Still quite a bit of slowdown. And let's see, refresh map. Yup. It went down by about 9.5 megabytes of garbage. Okay. Well, that definitely helps. Well, we might call that a night. End on a high note. Got a fair amount of garbage cleaned up. Main thing though is that we found out that we can improve on Unity's default two-string call for colors, even if admittedly it was a very infinitesimally small amount. But it's more accurate too, so that's, I don't know. So it was an interesting learning experience at the very least today. There are probably several more redundancies like that, I would bet. So it'll be interesting trying to get rid of those unnecessary redundancies and clean up our garbage generation. In particular, I'm going to be really, really happy when I can, assuming that I can, really get down to the JSON parser and just try to get it as low as possible. If I can get the JSON parser to generate no garbage somehow, besides the actual like final two-string value that it returns, if I can get that to function, we will have a much faster, just in general game, because a lot of the stuff that's slowing things down on the custom adventure side is is definitely the JSON parser saving and parsing things, because that's outputting about a couple of megabytes of garbage every time it happens. But if we can get around that, that will immensely help us. The main thing, I guess, is going to be trying to get rid of this. So when we click on Zork, there's a slight lag. So trying to get around that is going to be, I think, the really big holy grail for optimizations. But anyway, I think that's a good place to stop for the day. Didn't get anything too particularly wow-worthy out there, but it was productive at the very least. So, I mean, we did clean up a fair amount of garbage, especially because we got rid of that 9 megabytes of garbage being generated every time you open the map. All right, so that is a good place to stop. As always, I want to thank you all very much for watching, and I will see you all next time.